We utilize a technology from NASA that is an incredibly quiet drill. This drill is incredibly quiet because of the piezoelectric transducer. The piezoelectric transducer is what powers the motor in the drill, but operates at a frequency higher than a human hearing threshold. So you don't hear that whirring and huzzing, buzzing noise created by normal drills. This drill operates around 45 to 50 decibels when underload. That is roughly the noise of birds chirping, rainfall, library talk, that sort of thing. So it's incredibly quiet compared to normal drills. And it's scalable. The larger the piezoelectric transducer, the more torque and more power you can get out of the drill. The quieter the transducer, the less power, and smaller. So it can go up in size and power, and variable how you want it to be. And there's also fewer parts in this drill since you bypass all the different mechanisms in a standard drill. The piezoelectric transducer simplifies it and makes it more cost effective. And as far as my interviews for this project, I interviewed many engineers and maintenance technicians at Baxter, a medical device company in Cleveland, Mississippi. My interviews were sort of scattered between different aspects of the drill. Initially, we decided to just see if it was a viable product having a quiet drill. Many of the engineers saw it being applicable at home, but discouraged use in the facility as it didn't have any advantage over their current uses. As far as we progressed to potentially use this in a dental setting, and that had favorable reviews in my department. However, across our group discussions, we decided to stick with standard drill usage. However, in my most recent set of interviews, one engineer was particularly favorable of the aspects of the drill, especially it being incredibly quiet, because he had just had a baby the following week. So it was perfect timing for him to realize how a quiet drill has a market and a necessity in this market.
We began our project by looking into new and unique applications for the silent drill technology. One of the top categories that came to mind was dentistry. We figured that there would be a large market for a quieter dental drill since most people do not look forward to going to the dentist to get their teeth worked on. The sound of a loud drill in one's ear adds extra anxiety and discomfort. Unfortunately, as we did our interviews, we realized that this idea would not be feasible. Most dental drills are already as silent as possible, and rumors of quieter drills have never progressed past the drawing board. We spoke with dentists and learned that the demand was not extremely high because most people would end up having the procedure anyways and just deal with the noise. Learning all this led us to scrap the silent dental drill and move on to another application.
So throughout the project, I'd say we had a total of about 3 or 4 different business ideas. The first one was to basically take the patent, license it, and then sell licenses to power tool companies so that they could kind of put the patent to use however they saw fit. That way we didn't have to rely so much on manufacturing processes, establishing a customer base, all that. The second idea was then manufacturing the base drill, which we would then sell to power tool companies. That way they could make it meet certain specifications, put their brand name on it, whatever. Then the third idea was totally different. We looked into dentistry and the drills they use to see if we could potentially improve the experience for the customers. We eventually decided that was not a route we wanted to go down. And then the final idea, which ultimately ended up being our final business idea, was to integrate ourselves into the research and development of a certain company's power drill research. That way we could better access NASA's patent. I did an interview with the patent attorney whose name was on the patent for our technology, and he recommended that we find a safer route to go into the market. That way they don't have as much risk, we don't have as much risk, and it's better for everybody. So I ultimately thought we should focus on entering the market with a company that's already established, because it would be a lot better for both of us, and it would make a better product.
So our value proposition is that this drill will be a silent drill. So this drill, it's not technically silent. It's going to make as much noise as about a rainfall makes. So a rainfall is very quiet if you really think about it. This drill also will be low cost. NASA's engineers engineered it so that the cost per unit is lower than the average drill price, so the drill will run from about 80, 90 instead of 100 and upwards, especially for a drill as powerful as this one that can drill through concrete. And so our customer segments include DIYers on Pinterest, handymen, home renovators, like landlords who want to fix up a unit or two, but they can only do it at night. So they can do that at night without disturbing their other tenants, which is really great for them. And then of course construction companies. So how we'll be doing this, our customer relationship, is that we'll be working out of another company's research and development office. So we'll be working for Black & Decker, DeWalt, or Ryobi, or another company like Steel. And so these companies already have a pre-established brand name, so we don't have to establish customer loyalty. And so we can utilize that company's resources, like their customer support, their distribution services, and so those go along with our channels. So along with that, they already have set contracts with stores like Home Depot and Lowe's, local hardware stores, places where they can sell their merchandise. And so we don't have to make all those contracts ourselves because the company has already made that.
So the cost structure of our drill is the initial development cost, such as research and development, and the salaries for the research and development employees, and then manufacturing costs per drill produced. The revenue streams is the sale of the quiet drill for around $90 per unit to slightly undercut the competition. The key activities is the refination of the product to meet the employer standards and to make the drill more user-friendly. The key resources is the NASA patent, the research and development facilities, and the manufacturing facilities. Our key partners are NASA because of the license, and a company that already has a manufacturer or already sells a power drill, such as DeWalt, Ryobi, Black & Decker, etc.